dry, dusty world where the record of liquid water is long gone. Here on Earth, we can see landscapes that remind us of the Mars of today we've come to know. These landscapes in Iceland give us a window into the possibilities of the Mars of the past. Here on Earth, the water planet, we can see the evidence of water in the rocks, in the landscape, everywhere around us. As we probe the secrets of the long-lost Mars, what was the Mars past like? We can see that here on Earth in juxtaposition. The possibilities of the Mars of today with the possibilities of the Mars of yesterday, just a few hundred yards apart. In fact, we're asking these very questions with our Mars exploration rovers. How can we read the record in the rocks and the landscapes, see evidence of the warm, wet Mars of the past? We ask ourselves, what can we learn from Mars about where our own planet is going? What will be the history of water on Earth in the future? And likewise, what was the history of water on Mars? I'm Dr. Jim Garvin, NASA's chief scientist for Mars exploration, and a geologist by training. One of the ways we seek answers to these poignant questions is by acting like geologists, both on Mars with our rovers, but also here on Earth. We read the record, the forensic record of the history of water in the rocks. We're going to do that here on Earth to help us understand Mars, just as we're going to do it on Mars to gain vision into where Earth is going. Around me, the smell of sulfur is in the air. I'm standing in this remarkable place here in Iceland, where the manifestation of volcanism is at every scale, grand and small. In fact, if I kneel down here, I can feel water that's too hot for me to touch from within the ground. So we have volcanoes here on Earth at every scale, down to these little fumaroles. But why are the volcanoes on Mars different than those on Earth? The gigantic lava shield known as Olympus Mons, as big as a third of the United States. How did it get so big? Why isn't it active today? Well, let me try to explain. First, Olympus Mons is so big that if it were to occur on Earth today, it would have broken apart into pieces, like the big volcanoes in Hawaii, even those here in Iceland. The Earth's crust is so dynamic, its plates ever moving. On Mars, we don't think that horizontal motion occurs today. It may never have occurred. Secondly, Mars is a smaller planet than Earth. It was born with less internal energy. And while it's going through its life, that is Mars, trying to get rid of all that energy, just like these little volcanoes, it didn't have as much. So it didn't have as much energy to produce volcanoes as long. So here on Earth, volcanism is omnipresent, under the ocean, here in Iceland, wherever. But on Mars, that record may have cut off, may have stopped. And yet, we're still searching for a part of the Martian record that may be preserved. A fossil record of volcanoes like this that haven't erupted in millions of years, perhaps. It's still an important question to ask because it's this kind of environment here on Earth and on Mars where we know there are all the ingredients that makes life possible. In fact, we're looking for the record of them possibly in the form of rocks, in the minerals and the incrustations on its surface. It may be that it's those kind of features we'll be able to find on Mars using machines like our Mars exploration rovers. And they tell us of the environments that we seek in the Martian past. So here on Earth, I'm experiencing volcanoes firsthand, and we're looking for the record of these kind of volcanoes on the planet Mars. This is what makes it fun to be a geologist. I'm standing on some of the most dynamic landscapes here on planet Earth. Active volcanism here in Iceland. All around me are the manifestations of volcanoes at their most primeval and dynamic scale. You see boiling mud pots in front of us with the grays of silica being deposited. They look like holes into the earth. And then right over there, the green waters of a boiling mud pool. They're beautiful colors, they're telltale signatures that would then become recorded in the rocks. You can see the energy of the bubbling from the gases from within the earth under pressure coming up to the surface. The gray is the silica, the green are the sulfurs. And then over here we have a steaming chimney, also known as a fumarole, where we have the gases from deep within the earth from a volcano producing precipitates, silica, sulfur, and other compounds right on the surface. This is a little mini ecology. Some of the colors reflect colonies of microbes that live in these systems. You can feel the hot gases coming out from within the earth. And in these boiling mud pots, these fumaroles, these solfataras, is the energy of geology and life come together. As you can see all around me, the steam is bubbling from the ground. I can smell the waft of sulfur. I can see the mineral deposits, colors of greens, grays, blues, yellows. These kind of minerals are the telltale signals of these kind of hydrothermal systems. And as we explore these on Earth, here in Iceland, we're looking for their record on the planet Mars. We think they must have been there. Where are they today? Are they all buried in the past? Look at this. Inside this simple little volcano, we have all the ingredients of life. We have minerals, hot, very hot air, venting, mineral deposits that we could potentially detect from rovers and maybe someday even from the orbit as we explore Mars. So here on Earth, we're using the power of the analogy to understand the planet Mars in an active volcanoscape. Over here, we can see what happens when the water and the energy from within the Earth produces a whole forest of mini volcanoes. You can see some of the beautiful colors of the minerals that are deposited, like travertine. You can see sulfur deposits, the grays of silica, the reds of iron oxides. These are the things we're going to be exploring for on Mars at the rock scale. And if we find them, eureka! We'll have signatures of these kind of environments on another world. Maybe, or just maybe, the record of these kind of places, like we see here in Iceland, are buried in the Martian past. And if we find them, we'll know that's a great place to look for the clues to what makes Mars work, how it's like or dislike Earth, and even whether Mars ever had life. And this is unbelievable. Here in this volcanoscape world of Iceland, we have a huge colony of life forms, a microbial world in its own right. Look at this stuff. Thanks to the action of water and warmth, these slimy oozes are a full microbial world. Volcanoes, water, energy, nutrients, sulfur, carbon, hydrogen, oxygen, nitrogen. There it is, the cradle of life. So now we have to find this stuff on Mars. One of the problems on Mars is these things are so fragile, they don't last very long. So preserving them in a long record, you know, in another world, even here on Earth, is tough. So you got to see them when they happen or have them get unburied so you can find them again. The hard part. They don't make it easy. This is soft stuff, you know. It's easy to find a hard rock. Here's one that's been oxidized with hematite. But finding the soft rocks, it's why our game isn't easy. But that's why we have the rovers. If we ever found these kind of things preserved as minerals, I think a lot of us would retire happy. Anyway, what a great place.